Hello everyone, and 'tis the season to be jolly, because you're done with your ALEKS. Today we're going to be going over writing a one-step function based on a table. Let's get into it. Here we are in ALEKS, and it asks us to, for the table of values, write a function when the input is n. So, this is hard to read. I've gone ahead and put this in whiteboard. Here we are in whiteboard FI. It's a little bit bigger and I can move things around and draw on it. Now you can think of a function as a machine. It's going to be an operation. It's going to be an operation that happens to each of these inputs that generates the output. Now, it being a one-step function means that there's only going to be one operation that happens to each of these inputs to generate the corresponding output. That means we might be adding or subtracting or multiplying or dividing, but not more than one, just a one step. So what happens to get 1 to 4? Well, certainly that's a bigger number, so we could be adding 3. Maybe our function, maybe our machine, just adds 3 to the input to give us the output. Well, certainly 1 plus 3 is 4, but 2 plus 3 is not 8. So that's certainly wrong. So what else can we do to get from 1 to 4? Well, the only other operation of our basic operations that makes numbers bigger would be to multiply. So 1 times 4 certainly is 4. So maybe our operation simply multiplies the input by 4. 1 times 4 is 4. 2 times 4 is 8. 9 times 4 is 36. So we need to know the output when the input is n, just a variable. Well, n times 4 is just 4n. So our answer is simply 4n. Let's do another problem, just to make sure we're familiar with how this works. All right, we have a similar problem here. I'm going to go ahead and transcribe this into whiteboard.fi. And here we are in whiteboard.fi. Now notice I didn't have to do much because I just had similar inputs and outputs. Well, at least they were in the same position. We still have this function that's doing something to each of them. It's doing the same thing to each of them. So how do we get from 2 to 4? Well, we could add 2. So maybe our function adds 2. Well, does that work from 6 to 12? No. So our function can't add 2. And what else could we do to get from 2 to 4? Again, 4 is a larger number, so we could multiply by 2. Maybe we're just multiplying 2 times 2 to get to 4. 6 times 2 is 12, that follows. 8 times 2 is 16. So our rule seems to be, our function is multiply the input by 2. The input's n, we're just multiplying that variable n by 2, so our output would be 2n. Now, not all of these are going to be multiplication. Let's find an example where we have a different operation. All right, here we have another example, and our numbers are getting smaller. So it's definitely not multiplication unless it's multiplication by a fraction, which I don't think ALEKS would do that to you. Yet. I will go ahead and transcribe this. Now my inputs are bigger than my outputs, so I have to do some debigulating. So maybe I'm multiplying by a fraction because scary things. You will have to do this later on in the year, but let's see. Because if I multiplied 5 by 2/5, I would get 10/5 or 2. Let's see if that works. Is 7 times 2/5 equal to 4? Well, 7 times 2/5 is 14/5, and that's not even a whole number, so that's certainly not the case. Whew. Well, what else could we do to make numbers smaller? Well, the simplest operation to make numbers smaller would be to subtract. How do we get from 5 to 2 by subtracting? 5 minus 3 would be 2. Let's see if that holds true for the other numbers. 7 minus 3 is 4. 8 minus 3 is 5. So n minus 3 is, well, n is just a variable. So n minus 3 is going to be n minus 3. Those are not like terms. We can't combine them, and we're done. Hopefully this makes it clear that you're really just looking for a rule that transforms each input into its corresponding output and treating n as a variable, because it is a variable. We don't know its value. So when we subtract or multiply, it just becomes n times that number, n divided by that number, n subtract that number, or n plus that number. I hope this video has been helpful and that you have a great day, everybody. Bye-bye!